guys are pretty well aware of this, but across Nebraska, our rainfall amounts vary tremendously, about an inch every 25 miles as you go from east to west, 34, 36 in the southeast corner to 14, 16 back there. This year, I think southeast corner is getting a little less than that. Some areas out here are getting a little bit more. The irrigation amounts that are needed are going to be just the opposite of that. As we move from the west, we're going to decrease typically the amount of water that's going to be needed on an annual basis.
So the ET gauge is a fairly simple tool, and that's kind of why we like it. Now, if you guys are fairly close to one of the automatic weather stations around the state, other states have those too. Those will give us those daily ET reports. Usually when you hear them on the radio, that's what they're getting them from, those weather stations. The question you always have is, we only have so many of those across the state. Like in Schuyler, our closest one is either at West Point or we have one at Monroe, which are both about 25, 30 miles away. So you start to wonder how accurate is that data. So what we can do is we can use one of these ET gauges to give us that same ET report that we want. We just fill this up with distilled water. Inside of here, we've got a suction tube. So that's the hardest thing we have to do every year, is just make sure we get this thing primed so you have suction. It pulls that water up into this top, which is ceramic, and the ceramic has fine pores, so water just evaporates away from this thing. Kind of like the reverse of a rain gauge. You watch and see how far it drops instead of how far it goes up each week. Nice thing with this is just put it somewhere that's convenient to get to. Edge of the field, ditches work well. Quite a few guys actually put them at the end of their driveway if that's fairly clear with no trees. Just go back every week and check the gauge and just see what the water level is. Once a week is usually good enough for most guys. The other nice thing with this, it usually represents a 4 or 5 mile radius at least, so you probably only need one of these. You don't need one for each field. We want simple tools that work for you.
When we plant the crop early, we don't have very much leaf area, so we're not having much evapotranspiration. We're having more evaporation. So we've got coefficients that we use along with that ET gauge. As the crop matures, gets close to tasseling, it's using its maximum water, and it's mostly going through the plant. It's not evaporation, and so our coefficients are higher. During that time, the coefficient's 1.1, and so early it could be a tenth. Here it's 1.
So what this does is you just find your growth stage here on the left-hand side. Find whatever your ET gauge dropped that week. So if it dropped 1.5 inches, like Gary mentioned, right now we're at V16 or silking. So you just follow that down. You find that we used 1.65 inches for that last week. Now we had the ET gauge drop 0.8 inches from, we filled that thing on Monday morning, and so it's dropped 0.8 inches in the last 3 days. With this corn at silking, we multiply that by 1.1, so that's about 88 hundredths. So we're right at close to 30 hundredths a day that this corn has used the last 3 days. Beans, right now at R2, that coefficient is 1, so the beans used 80 hundredths. So it's just kind of nice. A nice thing with this is something you can drive and see yourself. It's kind of that visual reminder. You might think that last week was really hot and dry and you used a lot of water, but if you see this thing and it only dropped 1.5 inches, it's going to give you that kind of, I don't need to irrigate as much as I thought I maybe needed.
This information we're posting on that water website, our Nebraska Ag Water Management Network site. We've got these ET gauges. They're just like Nebraska rain cooperators. They're posting that information to the website, so you can go look at it if you want. And if you have an ET gauge, we'd encourage you to go ahead and post it. You'll click on your county, and then you'll have a map like this where the ET gauges are. The red ones are where producers are posting them. We've got blue ones that are for automatic weather stations that it comes from the weather station every day. So these are posting weekly, and we've had some comments, well, my neighbor isn't posting his. Well, if it's a week old information, it's not going to do you much good. That's why we put the ones that are from the weather station. We're trying to get it changed that if they're posting on a regular basis, they're going to be red. If they haven't posted for a couple of weeks, they're going to be gray, so that you don't have to worry about posting on somebody that's not reporting. The automatic weather station is going to look like this. Any day you click it, it's going to click the day before its information. So we did this on the 14th, on the 13th. Our we're recording that page was using 1600 a day. The week before it would average 2100s, and this week it would average 2600. So you can go back and see what's happening any given day. So that way, if you don't have one, you have an opportunity to get that information. This slide, I think, summarizes a lot of what's been happening here. This is the week ending on like the June 5th. So I took the reading this day, so it's the day before. The ET gauge drops 2.25 inches for the week. The corn was in V4, so the coefficient for V4 corn is 0.18, so it used 0.41 inches. This week, it dropped an inch 75, it grew 0.61. This week, inch 35, it used 0.69. You'll notice that 135, 1 inch, 160, 120, the week that ended last Sunday, it dropped an inch 30. And it was at the V tassel 1.1, so it's like an inch 45. So you can see that our greatest ET gauge change is usually earlier in the season because it's drier, less humidity, more wind, but our actual crop ET is not very much.
You know, but texture does make a big difference. You know, the sandstone and clay, it just kind of shows us the size difference there. You know, a big sand grain compared to those little tiny clay particles. You can see why the water holding capacity changes a lot. So sand, that's a fairly easy one to try to estimate the percent sand. You know, if you feel grit, you know there's some sand in that soil. Silt, that one's kind of a hard one. I think to try to estimate. You know, usually it's easier to figure out your sand, figure out your clay. If you can subtract, you can get to your percent silt from that. So work around that one usually. And the last one, clay. That one are fairly easy to estimate, but a lot of times I think we would probably overestimate how much clay is in that soil sometimes. You know, if you want to, you can try it in the teeth method. I don't really recommend that one, but I'd use your hands instead.
You know, the soil scientists, when they go ahead and classify them, this is the kind of triangle that they use. The percent sand is here. So we've got low percent sand in the silts. The percent clay is here. We've got, okay, go across.
So, you know,
it's going to be lower on the amount of clay.
Yep. Yep. So pure sand is going to have hardly any clay, and then percent silt goes up. So we get down to this corner, we have more.
So we've got higher amounts of silt there, like that's about 60 or 75% is silt in those soils. So these are the various soils. The clay are up here, the silts down here, the sands in this area. So those are kind of the percents.
So the big thing that soil texture affects porosity, and that biggest component of that is just those particle sizes. So if you have big particles of sand versus those tiny clay particles, you're going to have a lot more pore size there to hold the water and hold air also. The big thing though with the sand, you have those big pore sizes, but it just can't hold on to that water. It's going to move down so fast. You need that attraction of that particle to. That's why you get too much clay, and it holds the water so tight that you can't even use it also. That's kind of the interesting thing with that Texas soil. Water holding capacity on that was
1.5.
1.5. It holds that water so tight. I think with that much clay, you have a lot more water out there. It doesn't work that way. Infiltration, we all know, if you have runoff on a sand, you're working really, really hard to get runoff on a sand. You don't have that. And then, we don't want to get to permanent wilting points, so usually we're managing our fields between field capacity and that available water. So, the one tool, we've had to check was those watermark sensors. What watermark sensors measure is soil matrix potential. That's a measure of how hard the crop has to work to extract the water. Kind of an energy status of the water balance out in that soil. You can get below 50% field of available water holding capacity. There's still water there for that plant. It just has to work so hard. And in conditions like today or yesterday, it's probably going to be stressing the crop. You're going to see some rolling of leaves and corn, things like that. With irrigation, we don't want to get to that point usually. So we want to use 50%. It's as dry as we usually want to get an irrigated field during most of the season.
This is what they look like. We've got some here. They're filled with sand. They measure that conductivity in kilopascals. Some of you use the handheld meter. We have the data loggers. Both systems will work well. If you've got a lot of fields and want to go from field to field, this works very well. Key thing, mark them well. Put them in that representative area. Don't put them in an area that stays extremely wet or that knob of that hill. You kind of put them where it's most representative. We put them right in the row is where we've been doing it. We're doing some test plots out here where we're putting them in between the row because they say it'll grab the water, it'll funnel down there. We're also trying to put them in a permanent installation in no-till and seeing what their numbers mean for various situations and stuff like that. This is a graph of the one plot right here. These are the dates. This is July 3rd, and we've got the readings along here. Here you can see it got to about 70, and then on that date we went ahead and irrigated. And what we used for the trigger was 70 and just about 38. We averaged the two. We had used about 1.6 inches, which is about 50% of the water holding capacity for the sandy loam soil, fine sandy loam soil that this was. And so they went ahead and irrigated. You can manually calculate your depletion for your various soils, or on the Ag Water Network website as well as Soy Water website, you can click on watermark sensor calculator. You put in the type of soil you have. What we have here is a fine sandy loam. Those readings that I just showed you on that chart, 70, 36, and 1, we hit calculate. It tells us we depleted an inch 10, 57 hundredths, a total of 1.67. So we were right at that 50% depletion when we went ahead and watered.
So, it's not too hard to get out there and put these sensors in the spring, mainly just finding the time to do it. So more and more guys, we think we'd have more success with them if we can go to a permanent installation at some point. We're starting to get a few of these out there to try and see how they work. The sensors, we've had them last 4 or 5 years easily, so if you're doing permanent, you get 4 or 5 years out of the system. That's not too bad.
It's a little early to be thinking about last irrigation probably, but I guess we're all always ready to think about that last irrigation. Another one of those places where you have to make decisions, you need to know your growth stage, whether it be R4, R5, etc., or same way here. This is kind of a ballpark figure. I'm guessing it probably is a little high estimate on the water use for each stage, but it's the most current information that we have. Your goal is to get that soil depleted down to that 50% at the end of the year so that Mother Nature refills it.